All right, line R2, we're in Learning Task 3, which is going to be describe device testing procedures. And it's probably the fastest one out of our whole R2 section over here. Whenever the project is almost done, one of the last things that we're going to do is obviously test to make sure it operates. If you just rely on the fact that you think you did everything correctly and walk away, more times than not, you're going to find out later on you're going to get callbacks that, stuff has not necessarily been hooked up correctly. So we do have this expectation that we are going to take care of doing some of that testing. When that testing is completed as well, there's also going to be, in some cases, a documentation requirement, really dependent upon the scope and the size of the job. If you're doing, single-family residences, probably not a lot that you're going to have to do. But if you're doing a large commercial building, particularly important ones like hospitals and things like that, absolutely everything is going to go and have a lot of documentation. Let's just talk about some of the documentation changes that you should be aware of. One of the ones you need to know about is going to go and be changes. Anytime that there's a print that is placed out there, the print is just done off of a electrical engineer who in a lot of cases never actually was an electrician, doesn't actually understand what's going on inside of the field, and that might not understand the components or the code. I can tell you numerous stories if you wanted to hear them, and if I wanted to tell them about times where I've had to argue with engineers and said, you can't do this, it is against our Canadian electrical code. We should be able to do this and this instead. And they hum on the haw, but ultimately they eventually always fall to the code because they don't want to be in a violation of that. However, in some cases, that's going to go and result in changes. Now, sometimes those changes can be good. You might be able to go with a smaller size of cable than what they might have been speccing for something. But other times, it's going to go and lead to additional costs where they have completely missed something that they should have had captured on there. And as a result, there's an expectation that you're going to go and put this thing in to make it right. Example would be a job that I once worked on that was a condo unit. And the engineer had forgotten to specify the dryer plug in every single unit. Thing went out to tender, and it was a massive, massive change order. And the electrical company I was working for made bank off of that job from overpriced chunks of 10-3 conductor and those 4-11/16 box and the receptacle and the breaker. But they were able to because under their initial quote, they had agreed to do the job for X number of dollars. Whatever that's going to be, we'll place this thing out here as being a six-figure amount of dollars. Whatever that was made out to be, they did that, and then the change order resulted in them having to go and do this. We couldn't not put dryer receptacles into all these places. They needed them, and so then there was a cost plus that was assigned to them. A lot of companies actually bank on change orders, being the point where they make their money off of the job, or the big money off of the job itself. As you're working through on your prints or on your job, you're also going to be documenting where you run stuff. There's this set of things called as-builts. As-builts are the original architectural or electrical prints. You're going to have a copy of them, but then whoever is the person in charge on that site is going to go and draw over top of them. They're going to document where you're running conduits, how you've planned out to get from this point to that point, if there's extra conduits in the ground. All of that stuff needs to be laid out because once it's hidden, it's impossible to go and find later. We don't usually as-built out, all of the individual suites inside of a condo. But if it's the main distribution or if it's like the parkade lights or something like that, super handy to have that so that you can get to places if there's, damage to conduits or stuff gets cored through, etc. These need to be maintained. They're supposed to be marked up strictly with red. It is not supposed to be, a litany of different colors on top of there. You're supposed to indicate changes via red. Document them on the plans. You're going to turn over that set of plans at the end of the project. These days, with how cheap, digital storage is, I highly suggest you take pictures of everything because the second you turn it over to the customer, that they're going to go and lose that in most cases. So at least you've got something to go back on later on if necessary. But you're going to go and take, pictures of everything. And then once you know that your as-builts are built to spec, you've finished, what you've actually put in the ground is all documented on there, that gets turned over later on. If there is going to be an extra, you always want to go and get that in writing. Any sort of a cost plus or anything like that, always, always, always needs to be documented because they have got zero liability on it. They don't have to pay you for it if you just decide that you're going to go and do it, if they don't ask you to do it. So what you need to do, if you see something that requires change, at this point as an apprentice, you would identify that to whoever is going to be the lead hand. Whoever's lead hand should then go and identify that to the site super, the GC, the general contractor that's going to be on site. And then the general contractor would go and talk with them. They say, yeah, we need to go submit in for an order. General contractor wants to go and complete these things under budget, but they also understand when changes need to be made. So the general contractor and whoever is going to be lead hand will go and submit for a change order, and the change order should get approved, and at that point you start that work itself. At the end of the job, all your manuals need to be turned over. I know we throw out, the paper in the boxes for almost everything as we pick those things up. But on a commercial job site, you need to keep one copy of each one. That's going to go into the shop drawings binder. So if it's a baseboard heater, if it's a switch, if there's any documentation that came with it, you keep one copy of it for every new item that comes on site. Keep that copy, place inside of a binder. You're going to turn that over at the end of the job. Some types of systems are going to be much, much more regulated than that. Take a look at Section 46. 46.102 over here talks about instructions. Complete instructions for the operation care of emergency power supply equipment or unit equipment that shall specify testing at least once a month to ensure security of operation shall be posted on the premises in a frame under glass. Now, this is Section 46, which we're going to cover more later on this week, but that's going to be my emergency lighting supply systems that I'm going to be dealing with. And so we're supposed to not only just maintain the documentation, we're actually supposed to frame it and nail it to the wall someplace. I don't think I've ever actually seen a framed set of documentation of manuals for these anywhere, but at the very least, make sure you turn it over and maybe the customer can go frame it if they are running out of stuff to decorate the walls with. Going back into these ones over here, for commissioning, if you are going to be doing commissioning, that's going to vary upon the scope of the project. Some types of commissioning systems, fire alarm commissioning, if you've ever been involved in that, involve every single device. You're going to put the whole fire alarm system together, device set up together. Then what's going to happen is you're going to have a separate governing body that's going to come in. It's whoever you bought your fire alarm system through. They're going to come in, they're going to take apart every single one of your devices, and they're going to test each one of them for a short, they're going to test them for an open, and they're going to test them for a ground fault. On most of my normal ones. The digital addressable types of systems are a little bit different in the testing way that we go about them, but it's still going to be every single device that gets gone through and commissioned. Commissioned just means it has been examined by a third party who's ensured that you as the electrician did not screw it up completely, and they not only know you did screw it up, they've actually ensured that it tests because they've gone through all applicable faults off of it. Lots of different systems will have external commissioning bodies. If you have got large-scale air handling, all of your HVAC systems are going to be, whoever is going to be supplying that is going to do the commissioning on that. We might do all the power wiring to, the dampers or things like that, bring the power around. They might do the connections, but then ultimately somebody has to commission. Same with security. Same with a lot of our large drives. In the cases of very large variable frequency drives or adjustable speed drives, those things can be up into the tens, if not hundreds of thousands of dollars. Which means that if you, as some hairy electrician out there, just go and scab that thing together and then turn it on, you can blow up some big money pretty quickly. And so in a lot of cases, the wholesalers will actually go and send out a tech. You've been installing an ABB drive. They will have the ABB representative come out there to do the commissioning. That person from ABB, all they're going to do is they're going to examine all connections, they're going to test all voltages incoming, then they'll power it on. You're not powering that thing on before they come in to do the commission. That's the very first time that a commission system should be receiving power is when the commissioner is there, because that's their job, is to make sure that, first of all, the power incoming isn't going to screw it up. And then they go through and then they give you your verification of that. Security systems, obviously, a bunch of other stuff. Generators, any other types of backup systems, UPS systems, lots of these have external bodies. Those you'll just, on the jobs as they become necessary, you'll meet those different sub-trades and you'll start working with them on them. For motor-driven equipment, they talk about the bump test inside of your binder. You should be familiar with the term bumping a motor. That just means a real quick, on-off. You're not sealing it in, you're not running it, you're just verifying the direction of rotation, because direction of rotation is obviously going to go and provide direction of operation. You run a pump or a fan backwards, the water or the air moves opposite to where it needs to go. So we'll oftentimes do bump testing as part of the commissioning, usually with the load decoupled. So if it's a belt-coupled load for fans or something, you might take those off and just ensure that the motor's going in the right direction. First, same with pumps, you can go and decouple them in some cases and run them, first just to double check that. You don't want to have one party who's going to be down there by the motor. You want to have another party that's going to be at the starter, and you're going to be on radio, and the person who's down there is going to say go. The other person goes boom, boom, on, off instantaneously. And then the other person should have seen that device start and then, coast in whichever direction it needed to go. If not, you reverse your direction. That's the whole point of it. It's just associating if it's working correctly or not. Last thing that they talk about over there was just the Megger. Once again, you've heard this reiterated time and time again. If you are doing insulation testing, which is a necessity for some types of systems, particularly high voltage systems, they want to make sure that your high voltage splices are going to not fail. So they're going to require some Megger or high pot testing. In those cases, make sure that those systems are going to be disconnected, that it's just the device itself that is being tested, because anytime that we're Meggering or doing high pot testing, we are going to values of voltage that are higher than what the system is rated for. If it's a 600 volt motor, I'm going to Megger that thing out at usually double. 1200 volts is what I'm going to be looking to go and Megger that thing out at. So you don't want that feeding back into the system where all the other 600 volt components, particularly anything that is semiconductor, are going to be able to be affected by it. All right, that is it for Learning Task 3. We are through the R2 line. Well, we're through the stuff. You've got still some self-tests to go through. And we can expect to go and see, lots of stuff from this on exams, because it's all code stuff, but you've mostly covered almost everything inside of here this year. I think that most of the code stuff that we've either gone through on the weekly code exams or some of the code stuff that has been just, explained in situations we're going through, capacitors and stuff like that, has covered everything that's required out of this ITA line. All right, that's it.